All right, boys and girls, welcome back to the drive-through for a special Friday afternoon edition of the. This might be the first time we've ever had a Friday afternoon live recording at the drive-through. Okay, special shout out to the Charnay brothers. I mean, I literally love those kids. They have done so much for me. They've taught me so much. They're the reason that people like me teach. All right, here we go. Obviously, I'm sure you guys know that we're going to start this lesson off with a bite in my cookie always oozes peanut butter. Okay? Repeat. A bite in my cookie always oozes peanut butter. Repeat, please. Oops. I forgot a word. A bite in my cookie always oozes peanut butter chips. Repeat after me, please. A bite in my cookie always oozes peanut butter chips. I mean, it's so easy to ooze chips, okay? This is called a mnemonic device. You guys know about mnemonic devices. Give me another one. Widmapoy. That's actually not a mnemonic device. That's an acronym. PEMDAS acronym. My very eager Aunt Sally always serves nachos? It doesn't work. Not a good. How about, please excuse my dear Aunt Sally, people. How about, yes it is. How about King Philip comes often for ginger snaps? Don't know that one? Kingdom, phylum, class, family, genus, species, order? I don't know. Alright, so look. This stands for angle. You're going to want to write this down. Angle bisector. Where are we? No, where are we right now? We are in America. So where should you write this down? Wherever you want. How about that? Okay, angle bisectors. They meet at the incenter. Did I tell you that this is extremely confusing? Okay. Medians. They all meet at the centroid. Altitudes. They all meet at the orthocenter. Would someone mind shutting the door? Thank you. And perpendicular bisectors they meet at the circumcenter. Okay? And I can tell you, like big picture, that's the most important thing. Knowing what matches up with what. And so that's why I've provided you with that silly sentence. A bite in my cookie always oozes peanut butter chips. Because if you can remember the sentence, you have a very good chance of getting all the matchups right. Now there is a problem. Anyone see what the problem is with that mnemonic device? There's two C's. Excellent, Clayton. Okay? So here's how I remember it. Medians. Where's the median when you're driving on the highway? It's right in the center of the two lanes. Or if you arrange numbers in order, where's the median? It's in the center. Or altitudes. What's another synonym for altitudes? Elevation. It is. What we use in this, what's the altitude of a triangle is also called the height of a triangle. Height is high. Sometimes if you go to the orthodontist, they knock you out with laughing gas. And that's how I remember it. Just telling you, just saying. That's how I remember it, okay? So, that's the challenge. You got to keep the C's straight. Okay? I'm sorry, the C's. Circumcenter, like this one I just get by process of elimination. Sorry. And you'll learn when we see the incenter that the angle bisectors are always inside of the circle. So, you got to, like, I hate telling you to memorize things. This is one of the very few cases where I think you're going to have to figure out a way to memorize these 4 pairs. Okay? Next. All right, so we're going to start out with centroid, and this is going to kind of follow along with your sheet that you have in front of you right now. Okay? I want you to look at the second and the third fact. Okay? Do you understand that those are actually the same fact? Like, I don't understand why they list 2 facts. One of them says it's 2/3, and the other one says that it's in a ratio of 1 to 2. Or 2 to 1. It doesn't exactly matter, but yeah. Well, like, think about it. If you break up a segment that was 9 units long, 3 and 6, that's what they're talking about. One is twice as long as the other. However, the ratio is 1 to 2. I don't know if that makes any sense. Okay, so look, let's put it into practice. Okay, so we're setting out on this one to find the centroid. How do you find the centroid again? Medians. What's a median? It goes from the vertex to the midpoint of the opposite side, right? So why don't we just, I'm not even going to use the midpoint formula, I don't think. I'm just, well, figure out your midpoints. I'm going to figure out mine how I want to figure them out. 2, 4, 6, 8, 10, 12, 14, up 2. Right 14 up 2, so I'm going to go right 7 and up 1. There's a midpoint, okay? Let's see, down 2, 4, 6, 8, and right 2, 4, 6, 8, 10. So down 8, right 10. I got to go down 4 and right 5. Okay, that's a midpoint for sure. And now I think I can visualize that is definitely a midpoint. So far, so good? Now, you have to use your straight edge here, because if not, you won't be able to identify your answer. So draw all 3 medians. And then I'm going to explain to you a new vocabulary word that you're learning today. Okay. Point of concurrency. That just means all of these lines will always meet at a single point. That point will always have a name today. So what's the name of that point? That is the centroid. Okay? And it's asking you, what is the centroid? So we're going to use our eyeballs in this one, and what is it? It's not 0, 2. It's 2, 0. It's okay, no problem. Okay? Libby?
Before I knew, like, to do that exact thing, when you were talking about, like, the central point, like, where it bounces.
Okay, so there's 2 things that I want you to know. When you picture Ben Charnay spinning his phone on his finger is right there. That's the point that balances out all the weight of the shape. Okay? Now, when you get into actual physics, things aren't so uniform and nice, so you're going to need calculus to figure out the center of mass. But when shapes are simple, and therefore geometric, then the center of mass can be figured out with geometry. Okay? The other important fact that we just learned, but now I want to explain to you what the heck's going on. If I call this little segment of that line x, then what is this segment going to be? That's right, 2x. And if I call this y, what is this going to be? 2y, and this would be, I'll just call it a because z's look like 2's. If that's a, what's this? 2a. You guys got it so far? Okay, now, what we're going to do is just going to do the odd ones together, just so you understand how you would use this. So, in the accompanying diagram, triangle PQR, medians are drawn. They intersect at M. If QM is 6, what is UM? Well, there's only two answers that I think make sense. Either 3 or 12. Excellent, Bobo. Okay? You literally have to judge this picture, which is not something we've done a whole lot, but that's why we're using straight edges. We have to be very precise. So does this look like it's bigger or less than the 6? So that makes it 3. And the answer is, who puts 1 as a multiple choice? That's terrible. It should be A. It is literally terrible. Okay, we're skipping 4 and going to 5. In the accompanying diagram, Mike, crazy Mike, is finding centroid G. If BY is 15, find the length of BG. This one's a little tougher. So what if I called this X, because I don't even know what it is? Then what would you call BG? 3x, or x plus 2x. X is? BG is? 10 units. Excellent. Okay? We feel good about this? All right. So now we're moving on to circumcenter. Go back through your sentence, maybe without looking at your notes. What's circumcenter again? A bite in my cookie. Perpendicular bisectors, right? Okay. Let's look at 3 cases. For speed's sake, I'm not going to use my straight edge because literally I got to get this done before the end of the class. I think these rough sketches will be good enough to convince you. Okay. Kids have a hard time with perpendicular bisectors because they can just come out of nowhere. So I'm actually going to start on this one. Okay? By the way, what did I just set up here? Thank you. An acute triangle, a right triangle, an obtuse triangle. That was done on purpose. Where does the perpendicular bisector start? At the midpoint. It needs to be a what? A right angle. So there's one of them. Okay? And I might need to extend this. Again, I'm just giving you guys a rough idea about this. Okay? This looks about right, don't you think? There's 2 of them. Does that look like the midpoint? Check this out. You see how they all meet at the same point? Okay. Where is that point? Okay, cool. This looks like it's close to being equilateral, right? So these are actually possibly going to go through the vertices. Yep, that looks pretty good. Where is that point? Okay, would anyone like to take a logical guess where the circumcenter is on a right triangle? Ben? Okay. Bethany? On is the right one. We got inside, we got outside. The third option is on. Where are the altitudes of this triangle? Well, 2 of them are drawn. Right? That's one of the altitudes. I'm sorry. I got that wrong. Perpendicular bisectors. Not on the right angle. You totally confused me. Uh-oh. It's going to be, you are right, Bethany. There's that one, right? And there's that one, right? And then there's that one. Notice all of these are supposed to be perpendicular bisectors. So, now, I'd like for you, I'm going to pause the video after I tell you, I'd like for you to fill in under circumcenter. You got some fill in the blank questions there. Do you know how to fill them in now? The circumcenter is inside, you can do whatever order you want, inside of the triangle if the triangle is acute. Just acute. Doesn't have to be equilateral. That's my fault. I just picked an equilateral one because you guys would know it was acute. And the circumcenter is outside the triangle if the triangle is obtuse, and it's on the triangle if the triangle is, okay? Your paper leaves out one of the most important facts about circumcenters, and that is that they are equidistant from the vertices of a triangle, okay? So I think the best way to show this is to use the right triangle version. Actually, I'm going to go about this backwards. I'm going to start with a circle. This is a widescreen mode, so tell me when that looks like a circle to you. Is that good? Okay. Now what I'm going to do in that is actually inscribe a right triangle so that its vertices are on the circle. You ready to start? Thanks, Brogan. Yeah, that's fine. It should be open. All right, so if we imagine this is this fact that I can't prove to you yet, but do you have any idea what this point also is? It is indeed the center of the circle. We're going to get to that, but we can't prove it yet. And if you're wondering why are we randomly doing this, that's a great thing to wonder. This is chapter 13 in your book. We don't get to chapter 13 before your big test. This is on your big test. So we're just kind of getting it in because we have 2 days to play with before your exams. Does that make sense? And that's why I can't explain that to you yet. But now maybe you are able to believe that what's the relationship between these green lines? And how do you know they're all equal? Because all radii are congruent. So all this stuff we're learning is all adding up, okay? Do you believe me? So, the important fact about the circumcenter is that it's equidistant from the endpoints of the triangle. Now, if you go back, I'm going to pause for a second. The cool thing about this is if you go back to this, it's still true. Yeah, well, it's got to be. I mean, it always works. So this segment is the same as that segment, is the same as that segment. And so you can imagine that a lot of these things, that's a perfect circle, are coming from circles. That's where a lot of these facts are coming from, okay? Okay. All right, now we're going to talk about incenters, okay? The incenter is formed by the intersection of the angle bisectors. So now what I want you to do is just kind of draw a triangle, and this is ghetto math, that's okay. I want you to just eyeball it and try to cut that angle perfectly in half, and try to cut that angle perfectly in half. Okay? So what you've done, in your head at least, is that. Okay? And the cool thing about this, I don't know if you can imagine this, but this incenter it forms a circle that has now been wrapped around, the triangle wraps around it, or it's been contained inside. And you don't even know what tangent segments are yet, because we're doing this out of order, but that's a tangent segment. That's a tangent segment. And that's a tangent segment. Okay? And so, this gets me to my next slide. The incenter is equidistant from the sides of the triangle. So I'll give you a little bit of time to write that down somewhere. This point is the same distance from every side of the triangle. Now maybe that brings a great question into your mind. Maybe in your mind you're asking, how the heck do we measure the distance between a point and a line? It's the closest possible, it's the shortest possible distance. Or, what's the difference between that line, the pink line, the green line, and the blue line? The blue line forms a right angle. And once again, that is why your doctor tells you to stand up straight. He's not telling you to stand up tall. He's essentially telling you, or she, because most of us have girl doctors probably, she is telling you to form a right angle with the ground. Got it? That's what they're doing. They're measuring the distance between your head point and the segment that you're standing on. Got it? So that's why when I draw this picture, to measure the distance between the center and the side, you've got to form a right angle. And so this black line is not the distance. Okay? We're almost done. Okay, I promise. All right, I'd really like to wrap this up in the next 2 minutes. All right. Look, this is going to be quick. Altitudes. Where is that one? Inside. Look, this is what I was doing before for Bethany. She had me convinced she was right. Isn't that one of the altitudes? Isn't that the other altitude? And this would be the third one. So where do the altitudes of the right triangle meet? On the triangle. And it's weird finding the altitudes of an obtuse triangle. This angle is easy. But where is the altitude of an obtuse triangle from one of the acute angles drawn to? Yeah, you got to extend this line and draw it like that. So now I've got to extend that line, extend that line. I should extend the lines in a different color, not in pink. Let me extend the line in a blue dotted line. Okay, and now I need to extend it this way, I think. And the third altitude would be here. And that's going to be hard for you to imagine, and I wish we weren't rushing through this, but it's okay. I think you guys believe me. So where's the altitude? Sorry, where's the orthocenter of an obtuse triangle on the outside.